So I'm Brad Miller. I'm the head of developer relations at Electric Coin Company. And I'm going to do a short introduction to our reference wallet code, which was a project we prioritized last year. I'm assuming most of you have heard of Zcash, but if not, we'll do a quick intro. Our mission at Electric Coin Company is to empower everyone with economic freedom and opportunity. And the way we accomplish that goal, and the way we believe it will be accomplished, is through the use of open, permissionless blockchains. Except there's one caveat, which is strong privacy is necessary for any economic system to really succeed. So we accomplish the goal as the Electric Coin Company by being the primary developers and maintainers of the Zcash blockchain. As a quick intro to Zcash, it's kind of a unique system. It looks a lot like Bitcoin in a lot of ways, but there is one aspect that's very unique, which is the technology that we develop. That's the Z-address shielded functionality of the currency. I wanted to go through our different kinds of addresses because it kind of prefaces the entire reference wallet project. So if you're using Zcash, we have this base layer that's we call T addresses, transparent addresses. They behave identical to Bitcoin. But the technology that we developed, the shielded transactions, use something called Z addresses. Those Z addresses can interact with T addresses in various ways, and it creates a system where you have fully encrypted transactions on a public blockchain, to where the only parties that can actually see the aspects of any transaction are the ones that were involved in the transaction or any of their delegated parties. Now, the Z-address functionality, the shielded transactions, it's a very unique technology, but it's also very cutting edge, very new. Up until last year, the Z-address transactions were actually fairly inefficient. They were fairly slow, and it was really hard and almost impossible at that point for a mobile phone to actually generate a shielded transaction. So last year, in October, the Electric Coin Company proposed an upgrade that we titled Sapling, which increased performance of our shielded transactions by multiple orders of magnitude. And the Zcash community accepted that proposal, and it went live in October. So now that we have transactions that are actually small enough and fast enough to go onto mobile phones, we realized that the next step is we had to use our expertise to drive forward adoption on mobile by providing the cryptographic foundations. Why mobile? Well, a lot of it's pretty obvious. I mean, it seems like the first good use case of crypto, peer-to-peer, and also in-person in commerce. To make that happen, we realized we had to offer a few things. We had to handle the hard parts of the cryptography. We wanted to make sure that people were handling privacy appropriately. And we wanted to make sure we were providing libraries that were compartmentalized enough that developers could build upon any of the pieces that they needed. So we targeted Android first, and that's what we've released as of a couple of months ago, and we're working on iOS now. So why did we have to go about this as a company? I mean, we're protocol developers, not necessarily mobile developers. This is a snapshot of the wallet ecosystem right now. There's a lot of big players providing wallets for Zcash. But primarily, so you have these on mobile, but primarily they're using T addresses. They're not actually using the shielded technology that Zcash is built for. We realized that we're going to have to actually be the ones, the forcing function, to make sure that the cryptographic portions of the Zcash protocol can make it onto mobile. So we set out to create a set of libraries to do a few things. Obviously, to send and receive Zcash on an Android phone. But we had some other goals, too. We wanted to make sure that we were prioritizing user education. So we used this as an opportunity to make sure that we were educating people, especially doing user research around people that weren't necessarily familiar with cryptocurrency, to bring up awareness of Zcash. We're using it as an opportunity to make sure that people are using appropriate steps and understanding what being their own bank really means. And we also use it as an opportunity to educate why privacy is so important and why privacy should be the default feature that people use, especially once we get these mobile wallets into the public. But we also had some strong UX goals. So we wanted to make sure that we could present to people a few things. One, that it was easy to access quick and secure financial information on their wallet. One of the things we learned is that interactions with crypto in general for normal people is kind of a scary thing. So there were a few points that we really wanted to emphasize. Understanding your balance at a glance, knowing where your money is, both in the crypto native and in its fiat equivalent. Clear transaction status. Even people that are in the space, all of us have had that moment when we tried to send to somebody else, and there's a moment of panic when you think you might have made a mistake. And we realized that clarifying transaction status through the entire system is really, really important, especially to new users. And then making sure that we were actually giving users a lot of knowledge and info about their transactions. So we'll step through a few of the designs that we came up with, and then we'll jump into some of the core libraries. So a few of the things that we realized that quite a few wallets in the market right now aren't doing, but that users, especially non-native users, really wanted were clear balances. So we went ahead and put that front and center. You load up the app. That's something that people really desired. Transaction status. In a lot of wallets, this isn't very clear. It's kind of an afterthought. I think a lot of developers take the approach where once a transaction is submitted, the user shouldn't have to care. Unfortunately, that doesn't really provide enough information to give people peace. So we put transaction status as a top priority right on the home screen. Some other interesting findings. So this is your normal receive screen. Most wallets have this, the QR code. Our lead user researcher did a lot of research, especially with users not used to using cryptocurrency. And one of the interesting things that came out was segmenting the address in this way. So you can see we actually split it up into multiple pieces. So instead of being this daunting, huge, long string of characters, it feels a lot more like a phone number. It's these bite-sized chunks that people can look at. It's very easy to verify your address. You can look at the first chunk, the last chunk. You can probably feel pretty confident at that point that you're sending to the right person. And then the send flow. So there were a couple interesting things that we found here. One of them, a lot of wallets, when you paste in your address into the single line text field, you have to scroll across to really verify the address. Scrolling is not really a native touch action. So we actually display the address by truncating the middle, displaying the first and the last. That got a lot of feedback from users. It was a lot easier to actually, look at and use and verify and feel comfortable with. Okay, so that's the design side. Now we're going to do a really quick overview of the actual libraries that we developed. And then we should have a few minutes for questions. So we focused on Android. And we approached it from the angle of, if I'm a developer, how does this make my life easy? So starting at that foundation, we know that we have to deal with the cryptography of Zcash, we have to deal with preserving privacy, and we have to make sure that from a developer's perspective, the output of this is something that's useful. So this is the system that we came up with. There's three main components. You have the Light Wallet D server, which is in the top left of this diagram. You have what we're calling a Rust welding layer, which is our core cryptography. And then you also have the large blue box, which is the SDK that binds them together. The Light Wallet server is how the app actually consumes blocks. It wasn't an option for us to actually take the app, go query a server, and only get back specific transactions that we care about. That would have required us to delegate view authority of our wallet to some other server somewhere else. That's a privacy-violating design. So we said the alternative is we have to download every block. It's pretty obvious we're not going to download gigabytes and gigabytes of blocks to put it on your mobile phone. So the Light Wallet D server is a stateless server that takes in full blocks from a full Zcash node, condenses them, and then delivers them to the app in a stateless way. You can launch up as many Light Wallet servers as you need. You can arrange them in any way you want. You can have clusters. Being totally stateless, they can go up, they can come down. You can put them behind a load balancer, do whatever you need to do to deal with your user load. So those compact blocks, and this is one of the amazing parts of this design, a Zcash block is 2 megabytes. Compact blocks are about 3 orders of magnitude smaller. So that allows us to actually deliver every block with every relevant transaction to the phone. The only bandwidth that you're going to consume is about the same as scrolling through 4 Instagram images per day. You get complete privacy. You get all of your blocks on your device. No one actually has a clear view into the transactions or blocks that you're interested in. And then we have the Rust layer. So all of our cryptography at Zcash is written in Rust. The same that we use in Zcash D is the same library that we're using on the device. Obviously, Rust doesn't necessarily play nice with what Android or iOS want. So the Rust layer that we're creating is we're making sure we can compile and wrap it appropriately for both the iOS and Android devices. And it acts as the interface to take in the blocks and do all of the cryptography required to have a good interface with the SDK. And then the SDK binds them together. All right, so that's kind of like a dive in, but we designed it to look a lot more like this. If you're using our system in its entirety, that's all a black box. This is all you really have to care about. You have an SDK. You can start up the SDK services. And then all you have to do is subscribe to various channels. If you need balance, you subscribe to a balance channel. If you need transaction information, you subscribe to a transactions channel. Now, we wanted to make sure that we were compartmentalizing all of the various pieces enough to where if this model doesn't quite work for your architecture, take the libraries you want. You don't have to look at it as a black box. You can take the cryptography. You can take the Light Wallet D. But if you want to develop it in the way we did, which is a single currency wallet, Z address only, you can launch it up this way today. So where are we going from here? So here's the actual libraries that I talked about. They're open source. They've been open source for about 6 weeks. And we also want to push really hard on these to get them out into the community, right? We're not necessarily mobile developers. We are cryptographers. We're really looking for developers that understand the mobile side to partner with us. We want them to take this code and run with it. And we want to support them in any way we can. So we open sourced everything we've done. There's documentation on all of them. You have the SDK. You have the Light Wallet D. You have the actual Rust components for the cryptography. Our next steps are finding partnerships with third parties, major wallets to really help us do research and figure out what needs to happen next. We're also going to do SDK how-tos and sample apps. The Zcash Foundation puts on a conference every year called ZCon 1, and we're actually going to be creating an app that uses testnet Zcash for all participants and attendees of the conference to buy swag and do those kind of things. And it's really going to be a big user research experience. We're going to understand how people can interact with this app, both to purchase goods and also to send to each other. So from our perspective, this is the first step. We've sent out the first ship, and now we're looking for people to really come back and give us feedback. We're open. We have public chats. Our wallet team is always available to help answer questions, to talk to whatever developer is interested in working on any piece of this. So if you're looking to build something that's unique, that will be the first of its kind in the market, that will be the most privacy-preserving mobile wallet in existence, come talk to us and build it on this. So, questions? No questions.
So if you're talking about privacy, right? So would you say like the person receiving the Zcash would not know or would not be able to track it back? Is that where the privacy lies?
Yeah. Okay, so the question was, when we're talking about privacy, does the person sending the Zcash, no, the person receiving the Zcash know where it came from?
Yeah.
So in the Zcash system, when you have a fully encrypted, shielded transaction, the receiver doesn't actually see the sender's address, right? So you know the amount you got because you received it, you know what your address is, but you don't actually see the sender's address. So even the recipient of that transaction doesn't necessarily know who sent it to them. Yeah.
So is that the key privacy component?
Is that the key privacy component? Well, there's a few layers, right? So privacy on a cryptocurrency can mean a few things. On-chain privacy is, do you know the sender, do you know the recipient, and do you know the amount sent? In Bitcoin, all those things are open. That's the opposite of private, right? That's fully public. In Zcash, a fully encrypted transaction, a Z address to a Z address, to the general public, meaning anybody who's running a node who's not involved in a transaction, the sender's address, the recipient's address, and the amount are all encrypted. You can verify that it's accurate and true using our zero-knowledge proof system. That's kind of that's the tech we develop, but it's fully private to any other party. Does that answer your question?
Hey, I was curious if there was any talk one way or the other on using these reference wallets to nudge users towards like using Z addresses rather than T addresses.
Absolutely. Yeah. I mean, listen, what we're developing is a private cryptocurrency, right? The shielded aspects of Zcash are what we're building. The T address component of Zcash was kind of, it's an artifact of how we launched. They'll probably exist in Zcash for a long time, but we would obviously prefer to see Z addresses used
Do
in the
you ever
majority.
think you'll make T addresses like red and say like, you know, don't use these, or like warning, this is public, or kind of like HTTPS and like HTTP in a browser or something?
Yeah, yeah, and that's great because that's actually the analogy we use for Zcash and Bitcoin. Bitcoin is HTTP, but that also implies that a T address in Zcash is HTTP. Shielded Zcash is HTTPS. So, yeah, I mean UX considerations like that, I could see those happening. We have a little ways to go.
Do you guys have issues with like audit compliance when it comes to privacy like that?
Audit compliance? No, because we have a couple of features that actually make us pretty, in the eyes of an auditor, makes it okay, right? So what's an audit? If somebody just wants to go in and actually see some details about transactions about a single party, they have their own keys, right? So I mean, they can see all the transactions that they've been involved in. And there's also a feature that we're developing out, and it's already in the spec and in our actual key structure called a view key, which is actually a key that doesn't give the holder any kind of spend authority, but it gives them full view authority into the transactions related to that address. So, you know, in a sense, for an audit, you could see a system where the actual holder of the address with spend authority could delegate their view key to whatever the auditing party was, and then the auditing party can see the details of that transaction and their history. So, you know, that's a similar system to an existing banking system, honestly. It just gives the holder sovereignty of their funds. Anybody else? Cool. Oh, back there. Just yell.
I was curious if you could go a little bit into how Z addresses are formed.
That's probably the wrong scope, but talk to me afterwards, because I have 11 seconds before I have to get off stage.
Okay.
Cool. Thank you, everybody.